So friends, this is the second lecture of our agrometeorology lecture series. Today we will see about the atmosphere, its composition and layering. Every time we are meeting with the new lectures and new information, the idea behind this is to educate, to elaborate the information about the course to the agrometeorology students as well as common audience who are interested to know the agricultural meteorology. Earth atmosphere, you know, in the universe there are so many planets and the star is there, but the universally energy providing, light providing, heat providing source is the sun. And till today, the existence of the human beings are found on the Earth's surface. Earth is rotating its own axis as well as around the sun. And Earth is formed by the 4 spheres. One is the lithosphere, second is the hydrosphere, and third is the atmosphere. On all these, atmosphere, lithosphere, and hydrosphere are interrelated to the 4th layer of the biosphere. That is, lithosphere means solid earth, soil. Hydrosphere means water is all water found under, on, or over the surface of Earth. Atmosphere means gaseous envelope surrounding to the Earth. Gaseous or mixture of gaseous envelope surrounding to the Earth's surface is called as the atmosphere. And all 3 spheres of the Earth is important for the all life which is existing on the Earth, that is biosphere. Biosphere requires all 3 components, all 3 spheres contribution, then it's sustained. So this is the atmosphere. Atmosphere layer of the Earth is considered up to the 100 kilometer above the ground, above the sea level surface, and as academical purpose, colorless, odorless, and tasteless physical mixture of gases which surrounds Earth on all sides is called as the atmosphere. So some particles, dust particles, solid particles, and also the water vapor, that is liquid particles also present in the atmosphere is called as the aerosols. So the chemical composition of gases is uniform in that is homosphere in the lower atmosphere, and at increasing the height altitude, then it is heterosphere. Atmosphere is a mechanical mixture of gases, contains huge solid and liquid particles, aerosols. Then the major component of nitrogen, oxygen, and argon remain in constant over the time of space. And that also there's some variable gases is there like the carbon dioxide, water, vapor. So graphically, if you see these pie charts, you understand it is clear near about 80% composition atmosphere is composed by the nitrogen, oxygen, and remaining is the very small contribution. But for the agricultural purpose, oxygen, nitrogen, as well as the carbon dioxide is very important, and some water content, that is vapor of the atmosphere, is also the important. If you see the cross-sectional area of the vertical cross-sectional area of the atmosphere, looking like this, the different layer, that is lower layer near to the surface, it is troposphere, then second layer is the stratosphere, then mesosphere, and then thermosphere, and then exosphere. We are related up to the thermosphere or the ionosphere. So if you see, this is the one small layer that is ozone. It is present in the troposphere at the height of 18 to 30 kilometer is the maximum, and this is an exosphere. So up to the this is the Earth atmosphere. Above that, there is in the inverse. There is also the space, and in the space between the Earth atmosphere and the space, there is small line or a small space is there that is called as the Kármán line. It is found up above 100 kilometer above in the atmosphere. So if you see the three-dimensional structure of the layer of the atmosphere based on the temperature, if we see this figure, this photographs, it is clear that in the lower layer is called as the troposphere, second is the stratosphere, third one is the mesosphere, and fourth one is the thermosphere, and above thermosphere there is ionosphere or exosphere. It is considered up to the 100 kilometer. The Earth atmosphere is useful for the living entity, for the life. And in between troposphere and stratosphere, in between stratosphere and mesosphere, and similarly mesosphere and thermosphere, one line is there. One layer is, small layer is there, that is called as the pause. Pause means it is stopped for a minute, for a while, because here you are able to see in the troposphere temperature is decreasing as increasing the height up to the minus 60 degrees centigrade. And in this region, in the pause, that is tropopause, is the temperature is constant. Again, in the stratosphere, temperature is increasing because ozone layer is here, and the ozone is called as the umbrella of human beings, umbrella of life, because all the ultraviolet radiation near about are absorbed by the ozone, and hence the stratosphere has the more temperature. In this layer, temperature is increasing up to the, again, some extent, and it is a constant that is called as the stratopause. Again, it is going to decrease minus 18 to minus 100 degrees centigrade in the mesosphere. Somewhat here is a constant. Again, somewhat it is going to increase, and in the thermosphere, continuously it goes to degrees up to 1000 degrees centigrade, and therefore it is called as the thermosphere. And as increasing the height, decreasing the atmospheric pressure. So this is the different layers or profiles of the atmosphere. This is the figure. You are to the examination purpose, or you write to the answer in the examination, draw such a figure. So the first layer, one by one, characteristics of the layers we have to see here. The tropo means the mixing of turbulence. Sphere means region. So region where the turbulence activity is more is called as the troposphere. The maximum turbulence activity is found, that is rainfall, cloud formation, lightning, hailstorm, cyclone, all these activities that is due to the turbulence activity of the atmosphere found in the troposphere. And the height of the troposphere at equator is 16 kilometer, and from pole 7 to 8 kilometer. In the troposphere, as increasing the height, decreasing the temperature, this is the phenomenon we have seen during the layering. And the rate of decreasing the temperature is 6.5 kilometer, 6.5 degrees centigrade per kilometer is called as the lapse rate. If the lapse rate of the dry atmosphere, that is called as a dry adiabatic lapse rate, and it is saturated atmosphere, that is called as the saturated lapse rate. Then 75% of the total gas, moisture and dust particles are present in the layer of the troposphere. Tropopause is the small line we have seen before. Then stratosphere, it is a seat of photochemical reaction. Like already explained, this is a blanket of human beings. The temperature increases with the height, and its height is 20 kilometer to 50 kilometer to 55 kilometer. Upper boundary of stratosphere is called as the stratopause. And maximum, I told, the maximum ultraviolet B, C has all the, and ultraviolet B near about most of the ultraviolet B absorbed by the ozone layer, and ultraviolet EA near about 50% or 40% is absorbed by the ozone layer. Then the maximum concentration of ozone presence in the 30 and 16 kilometer. It is a variable in different references. It may show you, but it is a maximum of 25 to 30 kilometer. And mesosphere, the most meteors burn up, and the height 50 to 80 kilometer above the surface, above sea mean level, and coldest temperature minus 19 degree observed, and the height as shown in the different layer in this way 7 to 16, 15 kilometer of the second layer, 18, and up to the 500 kilometer, that is exosphere. And in between the exosphere and the sky, that is called as the thermal line. Then thermosphere or ionosphere lies beyond the ozonosphere at the height of the 80 kilometer above the surface, extending up to the 400 kilometers. In which ion zones known as the ionosphere also. Then temperature increase again already it is discussed, and from this ionosphere reflects radio waves because of presence of multiple reflections of short wave radio waves from ionized cells results in the long distance radio communication. All the radio communication, TV and mobile and internet and all these things is possible to the reflection of these radiations through the ionosphere or thermosphere. Exosphere, outermost layer of the Earth, it is between the 400 to 10,000 kilometers. Density atoms is extremely low. Hydrogen, helium gas predominant in this layer, and temperature is decreasing at 6.5 degree Celsius per kilometer. So adiabatic lapse rate already I told, as increasing the height, decreasing the temperature. That is rate of change of temperature in ascending and descending air mass through adiabatic process is called as the adiabatic lapse rate. Adiabatic means thermodynamic transformation without exchanging. Thermodynamic means ascending or descending air without changing the heat between system and the environment. The change of the rate of temperature is called as the adiabatic lapse rate. Thank you. So I hope this presentation definitely enlightening source of information about the atmosphere.